Everyone, let's study about apoptosis. What is apoptosis? It is a pathway of a cell death wherein the cell activates the enzyme that degrades the cell's one's own nuclear DNA, nuclear and cytoplasmic protein. So there is a cell death because of release or activation of certain enzymes which will kill its own DNA or its own nuclear and cytoplasmic protein. But here one thing you have to remember, in apoptosis there is no inflammation, unlike necrosis. Why so? Because the dead cell and its fragments are cleared with little leakage of cellular content, as they are highly edible, leading to rapid consumption by the phagocytic cell. Once they are destroyed, once the cell destroys itself, what will happen? The phagocytic cells will find this highly edible. So they immediately resolve it, or they immediately phagocytose these tissue fragments. Hence, there is no inflammation in apoptosis. There are two causes of apoptosis. One is physiological, another is pathological. Physiological, you know that growth factor signals are very essential for proliferation of the cells. So normally some cells die and replaced by new ones, or highly proliferative and hormonal response tissue undergo cycle of proliferation and cell loss that are often determined by level of growth factors. Similarly, pathological apoptosis occurs when there is exposure to radiation or cytotoxic drugs. Now coming to important part of apoptosis, that is mechanism of apoptosis. So it is always apoptosis is regulated by a biochemical pathway which will control the balance between death and survival inducing signal. Okay, so when there is it is regulated by a biochemical pathway that will control the balance between death and survival inducing signal. And when there is death signal, so there is ultimate activation of something known as caspase. This caspase is our hero in apoptosis. This is the main reason for the apoptosis. Now I want you to write the full form of caspase in the comment section below. So there are two mechanisms. One is mitochondrial pathway or intrinsic pathway, death receptor pathway or extrinsic pathway. Now, intrinsic pathway. So there is growth factors and BCL2 BCL-XL family, which will maintain the mitochondrial membrane by holding backs and back, which are pro-apoptotic family. And to simplify, I can give example like this. So consider these are parents, okay, and backs and back are kids. They are very mischievous, and mitochondria, consider it as ice cream box. Okay, so this parent will make sure that kids don't open ice cream box and binge eat them. Similarly, this growth factors BCL2 BCL-XL, they will control this backs and back, which are pro-apoptotic. That means they induce apoptosis. They make sure that they don't destroy one's own cell. How? By opening the mitochondria or by destroying the mitochondria. What will happen inside the mitochondria? There are very dangerous enzymes like cytochrome C and various other proteins. So they make sure that they are not the membrane of the mitochondria is maintained. Backs and back are not activated. So this is done by BCL2 or BCL-XL. Now I told you mainly hormonal or highly proliferative or hormonal induced cells, they undergo apoptosis. So what will happen in that case? There is inactivation of growth factor signal or DNA damage due to cytotoxic drugs or due to radiation. So because of that, what will happen? There is misfolding of the proteins. This misfolded protein gets accumulated. This will induce BH3, a sensor. This sensor gets activated. This sensor, what it will do, it will activate backs and back. These mischievous kids are activated now. What they'll do, they'll insert into the mitochondrial membrane. Mitochondrial membrane is very tight and intact because they contain dangerous cytochrome C enzymes. But this backs and back, they'll insert a channel. So through which what will happen? Cytochrome C and various other proteins from the mitochondria are leaked. So what these will do, they'll come to the cytoplasm and they'll activate caspase 9. I told you this is our hero now in apoptosis. Extrinsic pathway is quite easy. There are something known as death receptor. These are TNF family receptors. Okay, and these receptor in the if you take this as a cell, okay, these receptors in the cytoplasmic end there is death domain. Okay, examples of this death receptors are type 1 TNF receptor, FAS CD95 receptors. For this FAS, the FAS ligand is present on T lymphocyte. Okay, this pathway is mainly involved in elimination of self-reactive T lymphocytes. Okay, so there is T lymphocyte which has got FAS ligand and we have death receptor, that is FAS. Now there is cross-linking. This FAS cross-linked with FASL. Okay, I told you this FAS receptor has got death domain. Through this domain, now FAS is cross-linked with FAS ligand. Okay, and this is the death domain. Via the death domain, so they bind to something known as adaptor protein, which will activate our hero of apoptosis, which is that caspase 8. So basically intrinsic pathway or extrinsic pathway, they'll activate caspase 9 and 8 respectively, and there is further additional activation of caspases. They'll induce or activate the enzyme which will cause degradations of one's own cell. This is about mechanism of apoptosis, definition of apoptosis, causes of apoptosis. Thank you.